Hey, Kyle, good evening. Thank you very much for the opportunity to talk about the rib in a box. I think what I'll do is I'll digress a little bit from the upfront part of the presentation, which is a lot about the why of the rib in the box, and talk about how we arrived at where we are today with the rib in a box as a technology, a solution, and approach to DXing.
Yeah, sounds
So,
great.
back in 2017, might have been 2016 at Dayton. Um, I was at dinner with a group of fellow DXpeditioners, and George AA7JV was there. And we got to talking about this idea he had for a rib in a box. And the rib in the box as a solution is a self contained, remote controllable, remote operatable, 1.5 kilowatt HF radio. But beyond that, it's the rib in a box is really the bigger picture is a new approach to de-expeditioning, where the focus is on minimizing the impact environmentally that is a major concern of some of these entities that are managing these protected locations,
Right.
and hopefully enabling us to do more de-expeditions into areas that are, under management of fish and wildlife, or the French equivalent of TAF, just in hopes of advancing the opportunities of the fellowship among ham radio operators, de-expeditioners, and hopefully building more solid relationships with the management entities of the protected areas.
Right. Right.
So it's kind of a tongue-in-cheek approach, but new recipe for ribs. Um, And the basic premise is that the DXpeditioner has to be on the island, DXer has to be in the chair
Right.
in order for a contact to take place. This was Scarborough Reef back in the early 2000s,
Yeah.
where they basically set up these scaffolds to operate from rocks, and most DXpeditioners are familiar with these pictures.
Right.
And so here's a list of the top 25 DXCC most wanted entities. And you can see that North Korea is at the top, and Beauvais, which is hopefully going to get activated later this year, is second. And most of these entities are protected islands or environmental areas.
Gotcha.
All are restriction. 21 of 25 are islands, rocks, atolls, or reefs. And the big goal here when planning these expeditions is being able to get the yes,
Right.
and conversely avoiding the no, because navigating around the no is one of the big challenges to getting approval to go to these entities. And a lot of them are managed by environmental organizations, governments, military, some cases private governing bodies, and often a combination of any of the above. There's a number of locations that are both environmentally protected areas that are also managed by one branch of the military or another.
And usually those are not U.S. military; it's foreign military, right?
It could be foreign military. There's a few that are managed by like Johnston Island. It's managed by the U.S. Air Force in conjunction with Fish and Wildlife Service. So it's sort of a checkerboard of management entities out there.
Gotcha.
So the point being is, George had this idea of minimizing the impact, and he mentioned it, and we didn't cross paths again for a few years. And Hal W8HC and I were working on an effort to activate Chesterfield Reef in the Coral Sea. And, we were moving along through the process, securing a suitable vessel, and starting to apply for approval from the conservation group in New Caledonia when the COVID outbreak started. But I remember that George was working on this project. And so I reached out to him. Not only was he working on the project, but he had been to New Caledonia before, or to Chesterfield before, so he had a lot of insight and intelligence that we could fall on. But he was there before it became a protected entity. So we started talking about the rib and the opportunities, and about which time the Northern California DX Foundation took up some interest in this. And there was funding made available from the Northern California DX Foundation in a partnership with Flex to build 6 of these ribs.
Gotcha.
And so we built the ribs, and a year ago, November, Hal and I got invited to go down to the Bahamas to do some testing with George and George's colleague, Mike KN4EEI. So I'm just going to kind of scroll through these slides. Most of this is kind of a rehash of before, and my involvement in this project has been more on the technical side of things. But if you think about conventional DXpedition, you've got essentially you're building a small city.
Right.
You have sleeping tents, operating tents, common meeting area, latrine, generators. So it possesses a lot of the elements of a small town. And it's quite an endeavor to set up a large scale expedition. Typically we'll have 12 to 14 operators. And so you're looking at probably 2 to 3 days just to get the infrastructure set up.
Right.
So what you've expended is a man-month's worth of effort just to get ready to get on the air.
Right. And those expeditions, they run 24/7, don't they?
They run 24/7. Yeah. So typically, there's everybody you'd want to stay on the island, but in a lot of cases, you have people getting shuttled back and forth because you don't have the infrastructure to support everybody simultaneously.
Ah, gotcha.
And that becomes a further safety issue because you're shuttling these DXpeditioners who aren't in the prime of their youth anymore, back and forth from a boat in a dinghy. So it's complicated, and it's complex, and it's costly, and it takes a tremendous amount of effort. So, so nobody wants to make a mistake and look stupid or mess up. So, the rib concept really simplifies things. We've got the bureaucrat here, and he just wants to say no because he's primarily interested in protecting his managed area. So, kind of the theory of what I've been rambling on about here is we look for a way to get over the wall, under the wall, or around the wall.
Right.
And so here's our guy with the wheel, and so we came up with a new wheel, and it's really a great solution. It works well. It doesn't add a lot of technical complexity, but what we've really done is just move some of the technical boxes around, as I'll talk about in a little bit.
Yeah, you just displace some stuff, right?
We're displaced some stuff. So here's the rib. And that's George on the left and Mike on the right. And this is a large, I think it's called a Gator Box. Yeah. And these are waterproof, self-contained boxes. And there's the amplifiers are water cooled. Okay. The internals to the enclosure are water cooled. There's external radiators. It's really well thought out and well-engineered piece of equipment. And there's 6 of these in existence right now. And I would foresee that potentially there's going to be other variants of this box to suit the needs of specific applications or opportunities.
Gotcha.
So I touched on this a little bit earlier. This is a project with Northern California DX Foundation in a partnership with Flex. So George and Mike are the primary technical contributors. I've done some work on the networking side of things, and a lot in the wireless, the 900 megahertz wireless link from the boat to the island or to the rib.
Right.
I know you've been deeply involved with Node Red. Warren KD4Z.
Yes.
Warren put together a comprehensive monitoring and control solution based on Node-RED. And so we can talk. I don't know if you've seen the flows, but it's amazing.
I have not. So yeah, if you have those, I'd love to take a peek.
Yeah, I've got a slide somewhere where we did snapshots of the flows, and there's 3 or 4 slides that break it out in detail. But he's done some tremendous work on that, and I'll dig into that a little bit later.
Cool.
So the concept is pretty simple. You got radio, amplifier, control, and cooling subsystems, all in an environmentally controlled enclosure. Flex 6000 radio, they're 6500s typically.
Yep.
Home brewed, water cooled LD MOS, 1.5 kilowatt amplifier, 900 megahertz Ethernet bridge between the island and the boat, which provides more than adequate bandwidth and is very reliable. So where we can put the operators with Maestros or Smart SDR on the boat and use the 900 megahertz radio to provide connectivity to the island.
Now, why did you use 900 megahertz?
There was a lot of testing done earlier on. They tried 5 gigahertz, they tried 2.4, and with a path over a highly reflective surface like salt water, they just weren't unable to get the links to operate reliable. The 900 megahertz solution is actually a near line of sight solution. I mean, it works great line of sight, but being near line of sight, we could position the antennas primarily on the island and minimize the effects of reflections from the salt water.
Gotcha.
Which was key to getting the reliability up. It's amazing how reliable the applications are, even when the link is suffering from errors from multipath and other propagation phenomena.
Gotcha. Yeah.
So it's really solid.
Yeah, and I saw that. I don't know if it was a video or a picture of you guys bobbing around on a boat and shooting that link to the island, and it was like the Maestros were never missing a beat. It was, it's amazing how resilient that link was.
Yeah, it's the beauty of TCP. You've got retransmission of lost packets, and then the over-the-air protocol also has retransmission of lost packets and forward error correction. So there's a lot going on that makes it very robust and makes it work well.
Right. Now, do you have each rib gets its own dedicated frequency, or do you shoot all of the, like if 3 people are operating at a time, you shoot that over just one link?
It all goes over one link. So the network on the boat, and I've got a picture of this, but
gotcha.
You can envision a multi-operator station with Maestros and Flex.
Yep.
And instead of that Ethernet cable in between each radio and the PC or the Maestro, everything on the boat goes into a gigabit Ethernet switch, goes out over the radio, and then the reverse takes place on the island. The Ethernet interface on the radio plugs into a GigE switch, and everything's distributed over Cat5 or Cat6.
Right.
Now, the last trip, we did do a lot of experimentation with using Wi-Fi. We operated 4 stations simultaneously over Wi-Fi on the boat without issue. Gotcha. And we may look at using 2.4 or 5 gigahertz point-to-point Wi-Fi links on the island to facilitate this simplifying connecting to remote stations. So you may have a DXpedition and you might have a phone camp and a CW camp. Well, that sort of premise is, doesn't play here, but we may have a rib that's on one end of the island that supports the 160 meter and 20 meter station.
Yeah. And
rather than run a long length of Cat5, we would put up a point-to-point wireless link for something like that.
Right. Yep.
So the picture of that's George's boat. That's a 150-foot motor cat that he launched last year. Yeah, it's not rough at all. In fact, he's in the Bahamas as we speak, and he reached out to me and he asked me if I could go, and I've got a lot going on with my business right now, so I was unable to get away, but it gave me a chance to reflect, and I spent 2.5 months on the boat last year.
Wow.
So I was feeling a little guilty, But there's going to be opportunities in the future. I contribute here and doing projects that contribute to this effort. And I don't have to be there. If something comes up, I get a text message. I remote into the network on the boat, and I can do just about anything here from a troubleshooting and diagnosis perspective that I could do if I was sitting in the chair on the boat.
Yeah, geez. That's technology's great.
We'll dig into that a little bit more on some of the stuff that Warren's done. It's amazing. But so this is kind of a simplified diagram. Each of the ribs runs off of a 240 volt 2 kW Honda generator. These have to be sourced internationally because they're not available in the States. But obviously trying to run this off a 120 volt generator would be a bit of a stretch.
Right.
So the Honda generators only hold a gallon of fuel. So there's an auxiliary 5-gallon tank that siphon feeds to the generators. The tanks sit up on a table or a support. The generators sit on the ground. Once the generator starts to run, it siphons fuel from the auxiliary tank.
Right.
So there's a backup battery for the networking equipment in the rib. So if there's a power interruption, the networking can stay up. And this is in the case if we're daisy chain ribs, we don't want to have the head of line switch go down because of a power issue. So each of the switches is backed up with a battery, and there's some other cool stuff that's going on in there. We can support multiple receive antennas. They're all remotely switchable. Each rib can support 2 transmit antennas, and then a little antenna diagram showing a link back to the boat.
Now on the generators, so I've got an EU 2000 and take it out for expedition type style things, and I have noticed that if I do not ground that generator, throw a grounding rod in and ground all of my flex and the different things, my power supply, I get probably another 2 S units of noise. Did you guys experience that at all?
So the generators are grounded. The base plate inside the rib is a piece of 1/4-inch aluminum plate.
Yeah.
So everything is grounded to that, and then the power input to the rib is grounded to that, and the rib is grounded. So we've taken those measures to mitigate the noise that you can run into.
Yep.
So this is a complete station. This is your tools, your coax, your networking stuff, your radios, and the rib. So 2 guys can bring this on the island. And just to digress back to earlier, where we talked about it could take a man-month to get a major DXpeditions infrastructure in place. We've demonstrated from the time we load the Zodiac on the boat to bringing a rib on the island, we can have the first station on the air in 90 minutes.
Oh, wow.
You don't have to bring everybody to the island. 3 guys is enough. And so back to where I mentioned the rib is a technical solution and a DXpedition concept. We've put a lot of effort into coming up with a number of different antenna solutions that are all based on performance and rapid deployment.
Gotcha.
So, we've got vertical dipoles, and vertical dipoles are nice because they're independent of tidal action. Whereas if you have a ground plane, the tide goes in and out, the tuning on the antenna changes. Yeah. Because the water is the counterpoise. Well, with the vertical dipole, the water's not the counterpoise. It's a nice reflective surface to get a low angle takeoff on. But, there's, just little things we're working on. And, every trip we try something, and sometimes some things don't work. We've tried to consolidate antennas, multiple band antennas into one structure. And we learned that having all your eggs in one basket maybe isn't a good thing.
Yeah.
So it's a combination of, dispersing your risk or your failure potential over multiple antennas, but rapid deployment. We've got some vertical antennas that basically fit into a snow ski bag, and we can get 2 or 3 antennas in there, and 3 people can have 3 antennas up in a very short period of time.
Yeah, very cool. Very neat.
So this picture. So you'll probably recall our aborted attempt to go to Beauvais a few years ago.
Right.
And this is some of the stuff that we took to Beauvais. When I say some of the stuff, what's missing from this picture is all the shelters. So you've got your folding chairs next to the chairs. You've got your, these are our bunks. You've got the radios in the Pelican case. You got stuff for the galley. You've got this big thing in the front is part of a falling derrick solution that was engineered by DX Engineering for our 160-meter antenna. Yeah, so there's the flooring, which were basically 4x8 pieces of plywood on a wood frame.
Yeah,
they're not in this picture. So there's a lot of stuff here, but there's a lot of it's not in this picture.
Yeah, that is a lot of stuff.
So looking at this is all that stuff back in the container at Craig K9CT's place in Peoria, Illinois. So we kind of, I got with George N4GRN when I was putting this together, and I said, George, how much does this stuff weigh? And he said, somewhere between 12 and 13 tons. I said, okay, I can use that. And so in contrast, here we go. This picture here is on the back of George's boat magnet, and this is everything for the 160-meter station. So you've got fiberglass mask, rib, generator, quite a contrast. So we're looking at, for 6 stations, the total weight is only 6% of what you saw in the previous slide.
Yeah.
And it fits in a couple of Zodiac trips.
Yeah.
So that's speaking to the concept of the simplicity that the rib as an approach to DXpeditioning brings.
People don't.
Here's a few.
Yeah, people don't realize how much stuff goes on a traditional DXpedition.
It's voluminous. I mean, when we went to Navassa, let me back up. When we went to Desecheo in 2007, we got to Puerto Rico to learn that the helicopter that we had contracted was not going to be available. And so we scrambled and we got these 2 little Airstar helicopters. Well, we had so much stuff, it was somewhere between 45 and 50 helicopter trips from Rincon, Puerto Rico to Desecheo.
Wow.
I think it took 2 days.
Jeez.
But we had like our little own air traffic control system. That one helicopter coming in would come to the south side of the island. When it would leave, it'd go around to the north. It was just this big loop that they were making.
Wow.
But here's 2 ribs. And I'll go through in a slide or 2 here to each of the components that, in detail, and talk about what each of these little subsystems do and how it's laid out and why we did it this way. So here's the rib sitting on the beach, and there's 2 external heat exchangers. One is for the interior of the amp, the enclosure, and the other one is for the LD Moss amplifier. So the amplifier has a heat exchanger instead of heat sinks. So it's a copper plate, and it's got copper tube that sprays to it, and that's how the heat is transferred from the LD Moss amplifier and out through this 4-fan heat exchanger that sits outside the enclosure.
Right.
So here's a block diagram. And so it runs on 240. You've got 50-volt power supply for the amplifier, and obviously 12-volt supply for everything else, and 24 volts for PoE or 48 volts, excuse me. Lots of stuff going on in there. But what's really cool about this is that if you've ever run a legal limit station off of a generator, as soon as you hit the key, the generator bogs down, and then the governor's pulling the throttle open, and it comes back up, and just to do that again. And for a long time, the folks that I've done expeditioning with, we've argued over how much fuel we're going to burn. So in 2015, before we went to Navassa, I got tired of arguing. And so I took And we were using K3s and KPA 500. So I took a K3 at KPA 500, and I took a 200 watt light bulb to simulate a steady state load, like a PC and maybe a coffee pot or something else that might be running off that generator, and an electrical alarm clock. And I set up the macros in N1MM to simulate a DXpedition contact cadence on CW.
Yep.
And so I carefully measured, I ran the generator dry, carefully measured a gallon of gasoline, poured it in the generator, set the clock for 12 o'clock, set this thing up to run, and let it run. And I wasn't going to sit there and watch it.
Right.
So I went off and did my other thing and came back about 4.5, 5 hours later, and it stopped. And I looked at the clock, and it'd run for about 3.5 hours. And so I did some real simple math. And what I realized is that even though the generator's load was probably, if you compared it to a steady state 1600 watt load, which is what those are really rated for,
right?
Even though it was maybe 25% duty cycle, we were burning 93% of the rated maximum fuel consumption. So I go, okay, well, I tend to wake up early in the morning before the sun comes up, and then I start thinking about this stuff. And so I go, well, it's just like grandma taking her foot off it on the gas,
right?
Compared to cruise control.
Right.
And so George realized this too. And so what he did was he put a 75 farad capacitor bank on the 50 volt power supply output between the power supply and the amplifier.
Ah, gotcha.
So what it's doing is it's taking the ups and downs out of the generator, right. And this thing's keying it at 1200, 1500 watts, and the generator it's going up and down a little bit, but it's not throttling from, idle to, it's not going from idle throttle to full throttle and back.
Right.
And if you think about what's happening to the generators, every time you do an instantaneous high current draw, it's like trying to stop the armature. And then the governor pulls the throttle open and it spins it. Well, that's a lot of wear and tear on a generator.
Right.
And we've worn out generators on expeditions just from this hammering effect of the keying.
Yeah, you can almost tell what the CW is by the generator tone on what it's sent, or it's revving up and down, and you can almost you can hear the CW. You
can, and this smooths it out. I don't know how much fuel we're saving, but it's significant. I know on 5 gallons we can run for more than 24 hours.
Oh my gosh, really?
Yeah. So we refuel every day about the same time, and we never run out of gas.
Yeah. Yeah. Well, I think that's about right, because we run about 6 to 7 hours on a gallon of fuel, putting 3 or 4 radios. Yeah. Okay. Yeah. It works out.
So inside of the rib, so what you have going from right to left is the 50 volt and 12 volt power supplies.
Yep.
The ultra cap bank for the PA.
Yep.
The interior cooling fans. The LDMOS amplifier. Underneath this top box on the top that's got the NorCal logo on it is the Flex 6700 in this case. And in this box, the antenna tuner controller, the PA control, the data acquisition, all of that is enclosed in this box. And the original system was based on a solution from a company called Daisy Lab. And Daisy Lab is a commercial proprietary hardware, licensed software solution. It's actually basically the monitoring control system that George uses on his boat. George designed all the systems controls on both of his boats.
So he was familiar with it.
He was familiar with it, but the problem is it's expensive.
Gotcha.
In a scaled solution, it's economical, but this was not a scaled solution. So last February when we were out for, gosh, I forget what contest it was, but it was the trip we made in February of this last year. We were sitting around the dinner table, and I said, George, why don't you let me take a shot at this, see if I can replace this with something that's more economical. Well, I knew that I didn't have the ability to do it, but I knew somebody who did.
Yeah.
And so I got back, and Warren and I kind of touched base on this before I'd left, and we dug into a bit before. I wrote a really high-level functional spec. Warren's brilliant because he could take just basically, it was probably 12 to 15 lines of what this thing needed to do, and he embellished a very comprehensive solution, just kind of thinking through what we'd need with very little guidance. We went back and forth for a few months, and then we had a prototype done when we presented it to George. And I'm going to guess that there was probably less than 6 to 8 hours of additional work to fine tune it. So, I mean, he had it really close.
Wow.
And then so an Ethernet switch, cooling lines, a water reservoir, and coolant pump.
Right.
So here's sort of a high level definition. So the system has 4 basic functions. Control the PA settings, transmit, receive selection, and it all must be easy and intuitive. And the operator has to have a simple interface to look at, so he doesn't have to pay attention to it, and he can realize maximum QSO rates.
Right.
And the third is to prevent catastrophic failures when the operator's tired or distracted. So while there's, Node-RED's doing a lot of the monitoring, a lot of the protection is done in hardware because it's much faster.
Gotcha.
And so then it has to be functional enough and enable remote troubleshooting and recovery. So on this next slide, this was the Daisy Lab UI. It took up a full computer screen, so it needed to have a separate PC. It actually ran on a PC in the rib. So you had a PC in the rib supporting the Daisy Lab equipment.
Right.
And this was basically a VNC view into that.
Yep.
And this is what we came up with.
Yep.
This is a browser. It's a ribbon basically that you put up on the top of your screen. And in this snapshot, it gives you everything you need to know as an operator. The bar graphs are all color coded. Things turn red when there's a fault. And it's very straightforward. And Warren took it as far as to do per band power correction for the watt meters. So everything's very accurate.
You got a lot of space there too.
Yes. And so,
you got some space to put some more stuff.
Yeah. It's a little bit coarse, Node-RED and laying out the buttons and stuff.
It is.
But so there's another window here, which gives you the next level of visibility.
Yep.
All your current consumption here, manual control of your tuner, turning on the receive antennas, preamps, this sort of thing, taking the generator in and out of eco mode.
Yep.
And one more is this is the screen where everything is sort of, no two ribs are exactly the same. So we can go in and we can adjust all of the readings so that for that rib, all of the parameters that are monitored are presented very accurately.
Gotcha. Yeah. Yep.
And if you run into trouble, you reboot the Pi.
Yeah.
So Warren built in, and I don't know much about this, Mosquito.
Yep.
So the Raspberry Pi running Node-RED reports faults up to a Mosquito server in the cloud.
Yep.
And so Warren would text me, why is the amplifier tripping? Well, the operator wasn't paying attention. And so I tap him on the shoulder and say, hey, the guy back in the States wants to know why the amplifier's tripping.
So you guys had, so obviously the Raspberry Pi was on the boat. This was polling the.
No, the Raspberry Pi is in that enclosure in the rib.
So so you put it. Okay.
It's a Pi 4 with a there's a company here in Georgia that does an A to D hat for the pie.
Okay.
Pie plates.
Ah, yeah.
And so we got a pie plates A to D converter, and
so the pie is in the pie's in the rib. You're pulling. So the screen that you guys are seeing, that ribbon up there, that's pulling the pie that's coming over the link that's going to the boat, right?
Yeah, this is a browser view into Node-RED running on the pie.
Right. And then Warren's got his Mosquito, which is sending over the link, which is then sending over, I guess the boat has got some type of satellite internet going on.
When we're in the Bahamas, we actually have 4G coverage.
I gotcha.
You know, it's great. I mean, it's like being at home and being in the Bahamas. But there's also dual VSAT terminals on the boat.
Gotcha. So then he's pushing all that data up to a Mosquito server, which is collecting it, and then he's got some type of Node-RED, probably dashboard that shows all of the settings, where he can go back and come and see all of the rib settings within all of the control on one screen or many screens or whatever.
Yeah, and he's got text message notification.
Right.
So
it's
the
great.
whole thing is we can send some guys out on an expedition with this, and we will know that they're having problems before they probably know it themselves.
Right. And
you know, it sounds complicated, but you know, the only thing we've added to this really is the 900 megahertz link. We replaced a piece of Cat5 from the Maestro to the Flex with a 900 megahertz link. There's a couple Ethernet switches, but you don't have any problems with those.
Right.
It's you know, operator comfort, effort, scale, simplicity.
Yeah.
All these elements are pulled together.
So you don't have any, you know, I saw some ferrites in your picture there with in your rib box, in your Gator box. Did you guys have any interference issues or RF issues between the amp and the radio and the control interface setting right in there into the box?
You know, there are things creep up. You know, Murphy's always there. You know, it's a saltwater environment. Sometimes RJ45 connectors need to have a little deoxit sprayed on them.
Yeah.
We're real careful with saltwater contamination. So all the connectors are covered. We bring fresh water onto the island to drink, of course, but we also have fresh water in bags we hang from the trees to rinse our hands off. So you don't go into a rib without rinsing your hands off.
Right.
And then when the ribs come back, everything is thoroughly clean. There's no corrosion. We don't let anything corrode.
Right. Gotcha.
So you talked about, so this is sort of a high level view of the network. And if you were to collapse the island network and the boat network, it looks like just like a typical Flex multi-station.
Yep. Wow.
And, you know, with the degree of monitoring and control that we have, you know, we probably have more visibility than what's going on because we have a total systems view as opposed to somebody who's sitting in front of a Maestro and a Flex that doesn't have visibility into generators, network, you know, all these other things that you have problems with that you have to get up and try and fix.
Right. Yeah. If that guy doesn't know what's going on and it's 3 o'clock in the morning, he has to go wake 2 or 3 people to get back on the air. If you've got an alarm set that shows that you've got an issue with a piece of equipment, maybe you can solve it right there because you know what's going on versus troubleshooting a problem with, you know, a piece of equipment.
You just open up the next couple layers of the interface,
right,
and start digging into it.
Right, exactly.
What we also do is we upload simultaneously in real time to LOTW and ClubLog.
Yeah.
So instant gratification for the guys that are trying to work the expedition.
Right, exactly. I I've been in many conversations. I forget what it was. I think was it Christmas Island or one of the other expeditions where they were uploading within a couple of 15 minutes. And we were we'd work the DXpedition, and then within 15 minutes we knew if we had put them in the log. It was great.
Yeah, we had done that when we were on Navassa, and it was
maybe it was Navassa.
We rolled our own approach. What we did is we had a pair of Raspberry Pis sitting on the network, listening to the UDP broadcast from N1MM.
Yep.
And they were dumped into a database, and then we found that we could reduce the bandwidth by almost 95% by only sending up the QSO information that's in that broadcast packet and then zipping it. And we would send up 50 QSOs at a time so that we weren't dribbling across the satellite, but we were batching stuff up.
Yep.
And we think it was much more efficient. And I think that's along the line. Michael with Club Log is doing something that's similar. His solution is much more elegant, much more robust, because he's a lot better at this stuff than we are, but along the same lines.
Yeah, very cool.
So let's see, where are we going next? So earlier on, we were using Ubiquiti M900 radios. Unfortunately, those radios are no longer commercially available. We pick them up used whenever we can, and we've got a bit of a stockpile. They're very easy to use. If you're familiar with Ubiquiti stuff, all of it has an identical UI.
Yep.
So if it's done something with a router, you jump onto a radio, it looks the same. But the other solution we're using is a product from Cambium Networks, and it's a more complex radio, and it's taken us a little bit longer to get a handle on how it actually behaves. These radios were intended to be used by wireless ISPs, and using multiple input, multiple output, using cross-polarized Yagis. Well, cross-polarization didn't do anything for us because the antennas on the boat were vertically polarized.
Right.
So it's been we've been breaking some new ground. We learned a lot down there, and I took 2 of the radios back up to my place in Georgia and spent a few weeks characterizing them. Because when you're out there in the heat of battle, you fix something and there's all these variables going on. You really don't know if it's gotten better or worse, because TCP is taking care of a lot of the packet loss. And
right.
So I brought them up here and I played with them. We got a good handle on them. I built a couple of baseline configs for them to use, and they should be getting there tomorrow. And I guess I'll know this weekend how well it works. So we have Yagis on the island, space diversity. So this shows 2 of them, they're side by side. We usually do them diagonally. Then 2 antennas on the boat. And this is the other boat, Electra. And it's working real well for us.
You need Warren to build you some TCP data points in Node-RED. Have it report up to the interface.
Yeah, that's a good idea.
That's what. Yeah. Then you can monitor the bandwidth in real time.
He has no trouble keeping busy with stuff. We need to come up with a way to characterize radio performance.
Right.
Right. The user interface on the Cambium stuff's a little bit convoluted, but I've figured out the 3 or 4 metrics that I need to really, glean data from. So we're pretty close. So this is a pretty magnificent boat. It's built for expeditioning. Aluminum hull. 30,000 gallons of diesel. I'll tell you, it rides a lot differently when it's got full tanks gas than it does when it's empty. It's fun. We have a really great time. It's very collaborative.
I couldn't imagine being on that. It's just like the amount of money spent on something like that is just unbelievable.
Yeah, it's nice. I mean, and George is a brilliant entrepreneur, an inventor, an engineer, and it's fun because there are times when we yeah, everybody's challenging each other,
Yep.
and mistakes get made, but there's no we just move on.
Right. Right. Yep.
It's really collaborative. I'm kind of missing being out there.
Well, yeah. Why? I mean, you know, on a
Thanks for reminding me where I might have been right now.
what is it? 130-foot boat?
It's 150 foot.
150-foot boat. I like. Who wouldn't want to be on a 150-foot boat in the Bahamas?
And so this is actually on top, which is, I don't know, up
Yep.
on the top of the superstructure. You can see the solar panels and all. And
Right.
I think I came through the hatch and I banged my knee because it looks like I'm smarting right there. And George is looking over going, well, what did you do now?
Wow.
So the value proposition, the technology solution and the concept being both the rib is a minimal environmental impact, rapid deployment, nobody camping on the island. You might, I could see keeping a person or two on the island maybe, but we have that flexibility to do one or a hybrid approach. So
well, yeah.
None of this time wasted setting up tents, and there's a lot of fatigue that goes into that. You're in 115-degree sun. I'm 67 years old, and it wears me out.
Yep.
No wasted time moving operators and supplies back and forth. All your energy is put into operating. Vastly simplified logistics and transportation, lower fuel consumption. And so we've taken this and go, okay, so how does this approach impact how you shape the team? So, we would put 12 or 14 people out there, 8 stations. Everybody's on the air 8 or 10 hours a day, maybe more. And you're there for 2 weeks. And as you know, with propagation, especially over longer paths, there's sort of a 4-week ebb and flow cycle. You'll have some good propagation and then it'll tail off and maybe you'll have a sunspot or something and propagation will deteriorate and then come back.
Yep.
Well, if you're there for 2 weeks, you got a 50-50 chance of hitting great propagation or hitting poor propagation.
Right.
But let's say you do a team that's half the size and you stay for a month.
Yep.
You're not working as hard. And maybe, with a solution like the rib, you get a boat. Let's say it's not George's boat. Let's say we get a dive boat out of somewhere in the South Pacific. And we go out and we can operate a couple of locations in one trip.
Right.
Because we don't have all that stuff to haul.
Well, I just think of the fatigue of the operators. Even if you're only working 10 or 12 hours a day, the heat, I'm not in a comfort zone, all of that stuff plays into it. And who knows how many mistakes and busted cues you're putting in the log on, I can just, if you're sleeping in a good bed and you're operating in somewhat decent conditions, that makes it such a more enjoyable experience that you want to be on the air for a longer period of time, right?
Yeah, you touch on a very good point. And I have the most fun when I'm on a DXpedition when I'm not exhausted and I can sit down the radio, and I call it getting inside the radio, where I'm making cues, but it's effortless.
Right.
And, so you're copying stuff and, okay, did I get that right? Yeah, I'm 99% sure because, but when you're tired, you miss calls.
Yeah.
The fatigue plays a huge factor.
Yeah. I mean, I know after I've operated for that amount of time, it's like the last thing I want to do for another day and a half is look at a radio.
Mm-hmm.
But then you've got another shift.
Last day I was on the Vasa, I was on the air 14 hours straight, and it was 125 degrees in the shade.
Yeah, I don't know how you operate in that condition.
So I was on the first helicopter back to Jamaica. I wanted a shower.
Yeah.
I wanted a beer.
Right. Well, yeah, I love to camp, but man, do I love to take a shower every day. And that shower every day is such a morale booster whenever you're camping or whenever you're, if you can get some type of comfort, that makes it a little bit more enjoyable. 5 or 6 days of not having your creature comforts. Oh my gosh.
Yeah. So this is all, excuse me. This is a really fun project. I'm, still contributing. I like playing with antennas. So, I'll come up with an idea for an antenna and I'll ship the EasyNet file off to George. Hey, what do you think about this? And he'll send it back and say, hey, well, you did it for 40 and 20. And here's a variant I came up with. It'll work on 160 and 80. Simple antennas that we can run multiple, say 2 transmitters on simultaneously. That kind of stuff just brings tremendous efficiencies.
Yeah. I saw in one of the pictures you had one of the big, huge, probably it's 15-meter spider beams, vertical. Do you guys usually use some fiberglass spider beams to haul your verticals up, or do you put them in
that one's the big, I think it's an 18-meter spider pole.
18-meter.
We probably use 16 meters of it because the end sections get very small. And what we're using is we have it's a 160-meter vertical, but we make it fat by having multiple vertical wires that come out and are also actually part of the guys. So
gotcha.
And then it has a top loading wire.
Yeah.
And it goes up pretty quick. It takes 4 of us probably about, maybe 90 minutes. And then there's always some fine tuning that goes on after that 1 or 2 guys can do.
Right.
George designed and built a tuner that mounts at the base of the antenna. And it's semi-automatic, so it automatically tunes or you can manually tune it.
Right. Well, you're mostly running, so you just need to tune to that one frequency and go, right?
Right.
I mean,
but you do have the effects of tide. So the 160-meter antenna actually sits in the water. There on a sort of you got a vertical aluminum pipe that the spider pole fits over, and then there's 4 legs that are probably 4 feet long each that make the base up. But it's also the electrical return to the salt water.
Gotcha. So that makes the antenna come in and out of tune as the tide comes in and out, right?
Yeah. So at high tide, the antenna is definitely in the water. At low tide, it's out of the water.
Gotcha. That's cool. That's very neat.
But any questions? I think that's just about it. So this is George's shop at his home in Miami Beach. And, I've been down there several times now, but I'd imagine that if Nikola Tesla was alive today, this is kind of like what his shop would look like. And George does a lot of contract design work and consulting, and I'm not going to go into all the things that he's done, but it would stretch your imagination, some of the things that he's been involved with.
I bet so.
And
so on the first rib that you built, is that rib still in service? Like, did you have to, what was the process of getting this thing right to replicate it X amount of times?
So there were 2 prototypes built by George that are still in existence today. So there's 8 ribs. There's the 2 prototypes he built that vary a little bit. And then, so you call them prototype 1, prototype 2. And then the 6 ribs that were funded by NorCal would be the production units.
Gotcha. Now, do they have the control box that was what George put on the boat, or do they have something else?
This is one of the early ribs. If you look under the PC, you can see the board edge, and that's
right.
part of the Daisy Lab board. all 6 of the NorCal ribs have Pi 4s with Warren's Node Red solution on them.
Gotcha. Gotcha. Do you name them anything special? Like, do you give them like Star Trek or Star Wars names, or are they just 1, 2, 3, and 4?
The prototypes are 1 and 2, and the NorCal ribs are N1 through N6.
Oh,
just nerds.
Yeah, you should give them really cool names.
Yeah, that'd be awesome.
Yes, that's my contribution to the program. Wow. And so tell me a little bit more about the cooling of it. So, it's water cooled. I see in that picture, it looks like you've got maybe that's the pump or maybe the reservoir for
the reservoir sits on top of the pump.
Okay.
And so the pump circulates the water. Let's be specific and talk about the amplifier. So again, you got a copper plate under the amplifier pallet.
Yep.
And braced to that copper plate is copper tubing.
Okay.
And so the coolant gets circulated through the copper tubing. The heat is transferred from the copper plate to the water.
Yep.
So it comes in from the pump, through the tubing on the plate, out through the heat exchanger, and then back to the pump. It's a closed loop system.
So how cool does that, or how hot on each side, how hot does that water get, to that, the plate and then the cool come back in? What is that difference?
Probably 20 degrees C.
20 degrees C, wow.
So the amplifier idling would be about 30 degrees C, and they get up to about 50 degrees C. But it's really, we've got the temperature gauge on the UI, and it's very efficient.
Wow.
We shipped a rib to Warren to do some work on fine tuning the Pi, and he sends me a text and says, "This thing, it cools off fast."
Wow.
And I go, "It's pretty efficient."
How much does the rib weigh? You probably said that, and I didn't catch it.
No, I didn't say it. I didn't toss it. About 80 pounds.
80 pounds. Gotcha.
Yeah. So you've got to be careful if you're on like walking over rocks with it. But if you're just transporting it from storage to the Zodiac, it's easily transported. But yeah, it's in direct sunlight in 100-degree heat when you're walking over rocks in shallow water. You definitely have to be careful.
Yeah.
You have to be wearing the right footwear. Typically we wear it's foam rubber dive boots. Because they fit tight to your feet. They've got a sole on the bottom that's got a lot of grip, and they don't get sand inside of them. So
gotcha.
They're perfect.
Gotcha. Now on the Flex radio, do you take the Flex out of the enclosure that it comes in, and how do you cool that guy?
It's cooled by the air inside of the rib enclosure.
Okay.
And it's in the standard factory enclosure. Excuse me. We've had some short conversations, and if we had a 64 or a 6600, we might have to repackage it because they have a lot of air inside, and we don't need to package air. Right.
Yeah, the form factor between the 6600 and the 6700 is substantial.
Yes. So that's why these are all 67 and 6500s.
Right. Gotcha. Have you had any failures on the rib? If you have to think about it, I don't think you have.
not with the radios. I think we might have had damaged one of the amplifiers, but last time we were out, we decided to explore one end of the antenna spectrum and built a 5-band antenna that was running 5 kilowatt ribs on it.
Oh, wow.
And what happened was the feed point was a piece of fiberglass plate, if you will. And over the course of our time at the island, it developed a carbon trace inside the fiberglass. You can imagine porous.
Yep.
And so we started to experience some intermittent SWR problems. We took the antenna down and looked at it. It's like, I go, we're thinking the only place it can be is the feed point. So let's just rebuild it. So we had a piece of fiberglass on the boat. We replicated it. And we sealed the edges of the fiberglass with paint so that salt moisture couldn't get in, and it fixed the problem.
Gotcha.
It's just one of those learning experiences.
You're right.
That goes back to Warren texting me and saying, why is the amplifier kicking offline?
Well, very cool. I don't think I have any more questions. Yeah, I saw this. I don't know where I saw it. And then Sterling went down to, where was the DXCC? And it was in Tennessee. I don't think it was in Nashville.
W4 DXCC. This is actually the presentation from that event.
Okay. Was it in Nashville?
It was in Maryville, Tennessee, which is kind of like Pigeon Forge, Gatlinburg area.
Yeah, okay.
And we had a rib with us, and we were running it while we were doing the presentation.
Wow. Yeah. Sterling, he went down there and presented some youth things and sent me some pictures back and said, have you seen this? This thing is awesome. I'm like, well, I've seen a picture. I can't remember where it was. So that's what got me interested. Plus, with the Node Red, I was talking to Warren on the Node Red forums, and he's given me some insight on it. And then it's I don't do anything close to this, but we do a DX or an expedition style for Missouri QSO, where we go out and put, well, this year we put 6 stations on the air, all with flexes, all on the same network. And it was pretty cool where you could, boot up the one flex and see all of the other flexes on the same network. And we had, like you said, a CW tent and a single sideband tent and a digital tent where all of the guys were operating. And whenever I saw this, I was just like, oh, that would have made our setup so much easier. But we built basically individual stations for each operating tent and put 2 stations in there. So I was very interested in how this played out, and I was like, wow, if we would have had something like that, that would have been awesome. But so
you think about this, you could you can take the amplifier out of this,
right,
and shrink this down to something that's like a suitcase-sized Pelican case.
Yep. You have hit. I've been thinking about this for a long time after I saw what you guys did, to say, you know what, I could probably do this on a lower scale, but not have the amplifier, but just have something that you could put some flexes in, and put the switch, put the Raspberry Pi in, put all the connections in. You just basically take your radio and stick that in the tent with your antennas close by, and then bring everybody out to an RV trailer, and everyone operates in the RV trailer, and it's just all on the network.
Mm-hmm.
Right?
Yep. I've actually have a real small one. It's not based on a flex. Are you familiar with Hermes 2 Lite?
Is that like a Raspberry Pi type thing?
So what Hermes 2 Lite was, so I don't know where the concept got kicked off, but it's evolved over the last 6 or 8 years. It's a direct up conversion, direct down conversion, 80 through 10 meter SDR.
It's yes, that's what, yes.
It's built on hardware technology, FPGA, ADCs from cable modems.
Okay.
So you think about something that's produced in million unit quantities,
you
drive the cost down pretty low. And